Okay, last one is actually very easy. Okay, last one is actually very easy. It's not something like extremely bad. It's just like it's actually easy calculations. So what it's talking about is we have two distribution, right? We have normal distribution and we have binomial distribution, two distributions. Yeah. And the normal can be converted into binomial can be converted into normal. So that's the whole point of this exercise. So the normal approximation to a binomial distribution. So let's have a think. Your binomial become really, really, really large. Like your n is like 10 million or something, like really large. That is almost looks like a continuous random variable. So okay, this is actually a bad exercise here because you don't understand why, and it shouldn't be here. It should be learned in uni. Okay, so here you just remember, if binomial the n is large enough, then we can treat it as a normal distribution, but it's not that accurate. Okay, it's not that accurate. So that's the whole point of this exercise. If you ask me, when do we use this? Okay, the question will tell you when do you use that. They will say, use normal approximation to find this question. Okay, you are not decide by yourself. Do not just decide, oh, a binomial, good, a is 100, good, let's just do the normal one. No, okay, it's not like that. You must see the question says use normal approximation, and then you use it. Otherwise, just forget about it. Okay, do normal as normal way. Okay. So this is binomial distribution. So for a binomial distribution, if n is sufficiently large, okay, sufficiently large. So you may ask me, how large is sufficiently large? Okay, the testing is here. NP is greater than 5 and n1 minus p is greater than 5 as well. In this case, we treat it as large enough. Okay, n times p is greater than 5 and n times 1 minus p is greater than 5, then we treat that is sufficient large. Okay, otherwise it's not large enough. Say I have a successful read 0.2 and I have n equals to 10, they times together only 2. It's not large enough. It must reach 5 at least. Okay, that's sufficient large enough. Okay, so what it's talking about is, okay, if that's the thing, my x will then turn into approximately looks like a normal distribution. But what is the mu and what is the standard deviation? Okay, the mu is actually the originally mu for the binomial. So what's the mu for binomial? Is n times p. So you use this mu for the normal distribution again. Okay, you use that mu as the normal mu again. And the standard deviation for that is still the standard deviation for the normal. Okay, so NP1 minus P is the variance. Okay, NP1 minus P is the variance. So we should write variance here. So we still use that variance. Okay, we still use that mean. We still use that variance. And we treat as a normal distribution. We treat it as a normal distribution. Actually, I can't see any like easy things of doing that. Like they think that's easy. Okay, that's easy to change it into a normal. Yes, it's actually easy, but like in this exercise, it's not really sure out. Okay, not really sure why it's easy. But let's just have a look at examples. I'll just show you one example and it will make much sense. Okay, an exam consists of 25 multiple choice questions. Each question has 4 possible answers. Okay, at least 10 correct answers are required to pass the examination. Suppose that a student guessing the answer to each question. Okay, this is a very bad student. I don't know why, like they keep in probability session, they keep giving question like that. Okay, guessing every multiple choice. Don't do that in your exam. Okay, so 25. 1 on 4 is the successful read. Okay, 1 on 4 is the successful read. Let's say let x be the number of correct questions, correct answers. Okay. So x must be binomially distributed with 25 and successful read is 1 on 4. Okay, 1 on 4. So we can test NP. NP is 25 times that is 6.25. 25 times 0.25 is 6.25. Right. And 1 minus P is 25 times 3 on 4. That is, I don't know what is that. 25 times 3 divided by 4. That is 18.75. Okay, those two numbers all greater than 5. Okay, I'm just showing you that they are large enough. They're all greater than 5. And I can use the normal approximation. But do not do that unless the question asks you to do that. No, here. That's not the variance. I'm just testing whether it's large enough. That's the condition. It is large enough. Okay, that's all as normal what we did. Okay, so it's a binomial distribution with number of trials 25 and successful rate a quarter. Okay, a quarter. And then what is the approximate probability? Approximate, can you see like the approximate probability? So you are not using exact, you are using the approximation, stay even explicit, normal approximation. Okay, even explicit, normal approximation. The student will pass the examination. Okay, will pass the examination. What I want is probability that x needs to be greater or equals to 10, that I can pass the examination. Right, to have 10 to pass it. So x greater or equals to 10. But I'm not using binomial to calculate. If you use binomial to calculate, what we will do is manual 55E. Okay, number of trials 25, successful rate is 0.25, lower bound is 10, upper bound is 25, and then go enter, and I have 0.071 something. That's the exact rate I can pass that. So now I want to change that to a normal distribution. Okay, to a normal, I'll use normal approximation. So NP is 6 to 5, so I'll just go 6.25. And what is NP1 minus P? That's the variance. Okay. VARX equals to NP1 minus P. That's 25 times a quarter times 3 quarters. That's 75 on 16. Okay, SDX equals to 4. Square root 75 is 25 5 root 3. Okay, that's the standard deviation. Just square root the variance. Okay, square root the variance. So what I will have here is 5 root 3 over 4 and then squared. Okay, that's the standard deviation. So I'll use the norm, like the original mean and original standard deviation to treat this as my normal mean and normal standard deviation. So what I want here is probability x greater equals to 10. If it's a normal distribution, manual 552. Okay, I want that lower bound is 10. Upper bound is infinity because that becomes a like normal distribution. There's no boundary anymore, not 25. It's like infinity, and that becomes 6.25. And that standard deviation is 5 square root 3 divided by 5 square root 3 divided by 4. Okay, 5 root 3 divided by 4. Press enter. That is the approximation rate, 0.041. You can have a look. They're not quite the same. They're not quite the same. It's not an accurate approximation. So that's why I said it's a really bad chapter. Okay, it's not good. Okay, this method is quite far away from the actual answer. But like that's the way they want us to do. Just do it. Okay, just do it. So that's 0.0416. That is, I'll give you that 0.0713. Okay, that's the actual. Okay, actual. That's the approximate. That's the approximate. Okay, actual and approximate. You use binomial and you use normal. That's two different answers. Okay, that's the answer for A. Answer for B? What is the approximate probability that students guess from 12 to 14 answer correct? So I want probability 12 to 14 correct. Okay, 12 to 14. So again, you use normal approximation. So you will have 12 to 14. Okay, very easy. Normal distribution 12 to 14 means standard deviation. Enter that is 0.00378. So 0.0038. 0.0038. That's the approximation. Okay, that's the approximation. Again, what is the actual? What is the actual? The actual is menu 55E. Okay, number of trials is 25. Successful rate is 0.25. Lower bound is 12. Upper bound is 14. Is that value? It's quite far away. Okay, 0.0105. 0.0105. That's the actual value when you use normal. So do not use it unless the question asks you to do that. Okay, do not use it unless the question say find approximation. It's not a good approximation, and it's not large enough, and should be even larger than it's a good approximation. Okay.